Now I'm going to introduce Muhammad Basir, and he's going to do his presentation on pre-service teacher, science discovery, science as practices versus science as knowledge.
Good afternoon. Well, I would like to start with the National Research Council reports. National Research Council is like the most credible source for people in science education in our community. This council is supposed to vision where the science education goes. So, and its NRC has been consistently describing science classroom as a place where the students are actually doing science. It's like the students are supposed to act like a little scientist in the classroom. The model that they are drawing from comes from the science tradition. In science tradition, we always have senior scientists, junior scientists, student scientists working together as a community. The student is starting from a role of as a novice, getting the preferred role in that community, gradually over interaction with the junior, senior scientists, they are becoming like a scientist and getting the central role in that community. And it's actually successful model. It's survived for centuries, and it's like guaranteed the sustainability of science. Science, with this model, science is always passed from one generation to the other generation. So it's a nice model to have. And it's a nice model to have it in elementary classroom as well. There's just one problem. The students are okay. A student can act like a little scientist. The problem is, do we, as teachers, can do the act of mentoring? Acting like a scientist, are we really engaged with science, like scientists? Can we do the mentoring in the class while the students are doing science? Well, in science education, we have one solution. Hey, if we put students, pre-service teachers, in a class, and we just model what should we look like, the science classroom, then we are assuming that, hey, science educator can act like a scientist, mentor scientist. Pre-service teacher can act like not little, a little bit bigger scientist. And then we can learn together how to mentor elementary students. But again, there are some problems. First of all, when we have pre-service teacher in the class, are they really willing to do science? They come to a school of education with the assumption that, hey, I'm going there to learn how to teach. I'm not there to play the role of scientist. This is one problem. Are there any other barriers that pre-service teachers have when they come to school of education for learning science and learning how to teach science? One of the barriers, well, it's not just a barrier, it's also a positive thing that they have. But from the negative aspect, one of the barriers is that their background experiences when they come to the School of Education and learning how to teach science in this way. The barrier is their assumption about science is that it's a knowledge that they need to learn. It is kind of different than, hey, science is practice. So prior experiences, the prior experiences that pre-service teachers take to the classroom is actually the topic of this study. I wanted to know what are those prior practices, how those prior practices that they take to the classroom shaping the way that we practice science in the class. And I wanted to know when those things are mixed to what we are doing in the class, what would be the outcome and the result. The framework that I use is like drawing from social theories of language, Bakhtin, Vygotsky, Wittgenstein. They have kind of similar perspective about language and learning. And the simple assumption is that, hey, whatever we have done in the past is shaping the way that we are right now acting and talking. Like, imagine that I am not just this mind. My mind, metaphorically, has a tail. Back through my childhood, through the places that I grew up, through the places that I got my education, my early education, my higher education, and from all, and has another tail through my graduate study in the United States. All those things come together and make me, make the way that I talk and make the way that I act. So if you look at the action of a student in the class in this way, then their action becomes very complicated. It's not very easy to analyze. The other things that I'm using in this study is a specific way of looking at discourse, and this comes from the math educationalists. Math educationalists has developed a kind of a specific way to analyzing the discourse. They have some rule that they imagine that, hey, discourses have some rules that govern the discourse. Some of the rules are just governing the object of discourse. Like, look at the example. Last week I learned a lot about magnets. The word magnet is an object of science discourse. And this statement is something related to the object of science. The next one, I learned that pressure is related to the depth rather than the amount. A student usually thinks that, hey, pressure has to do with the amount of water. It just has to do with the depth of water. So a student mentioned that, hey, in the class I learned this. Good. This has to do with the relation between the depth and pressure. So I could say this is like a rule that governs the relation of those objects of discourse. Next one, everything should be fair, and you should only be changing one of the variables in order to have better accurate result in an experiment. This is quite different statement than the above. This statement actually is talking about like the meta rules of discourse. Has not to do with the object of discourse and the relation, but has to do with the way that we practice the discourse, the way that scientists do the science. So when I look at the student writing, I usually put their writing in two major categories. the one that is talking about the object level rules of discourse, the one that is talking about how we do science. The three questions that I wanted to know: how pre-service teachers talk about science, and how they are actually acting science in the class. I also wanted to know how they are talking about science learning discourses. What do they say about learning? How a student learns science. I also wanted to know how do they talk about teaching discourses, science teaching discourses. When they are talking about teaching, what do they say? And also I wanted to know the things that they bring to the classroom and interact with the classroom activity and practices, how those interactions create something new in the classroom. Data analysis, first of all, the data that I gathered was the weekly essays that the student wrote for the course. Every week, a student came to the class and were engaged with science practices, different science inquiries. And when they went home, they wrote 2 short essays about science. One of them was a reflection about what they learned. The other was like a claim and evidence paper that they claimed something about the things that they learned. They did about science. So I collected all those essays, like weekly essays of a student. It's like more than 1,000 short essays. I put all of them in NVivo, and I started to read and reread and recode and code all those essays. For the in-depth analysis, I chose like randomly 80 essays. And by coding those, I realized that, hey, we have 2 keywords in those essays: learn and teach. The students are using these words a lot, and those words are kind of including in those coded data that I have. So I was looking for a way to analyze all 1,000 essays. It was very difficult to do it manually. So I chose those keywords, and then collected all the sentences that include those words. It's like 4,000 words, 4,000 sentences. Those 4,000 sentences and the context around was collected as a data for doing a manual coding. And then I coded those extracted data, like a quarter of them, because most of them were redundant, similar to each other. So overall, the coded data was like more than 1,000 extra. Then I categorized those, and here's the result. What the student said about science. What science discourses that the student used when they were writing about what they learned. As you see, the red part representing most of the reflection, most of the things that they said about science. And it has to do with object level rules of science. It has to do with how pressure and depth are related to each other. The concept of science. 14% has to do with like just object of science. Today I learned about pressure. And as you see, the green part, like 17, like less than 30% has to do with science practices. So when a student talked about science, although they were in the classroom that they were engaged with science practices, every week they did science inquiry. Every week we had a discussion about science practices. When they reflected most of the time about science as knowledge. not science as practices. Less than 30% is about science as practice. When we go to the learning discourses that they use, we see the similar pattern. And just 23%, less than 25% of their statement were about science as practices. The rest, again, is about science as knowledge. What do I mean by science as knowledge? Well, they assume that science practices are good for a student to learn science. Look at the example. I learned that modeling is a great tool that allows a student to better understand information. What is the important things in this statement? Information. What is the important things for me is modeling. Modeling is there. I'm so happy that modeling is part of their statement. The problem is, when they talked about modeling, they didn't talk about modeling as science. Modeling is actually science. It's not a tool. It's part of science. It's part of science practices. They use it and assume that, hey, modeling is a process, very good. A student can go through this process and learn information. Most of their statement is similar, like experimental science practices. Doing experiment in science is good because it's a process that when a student go through, they can learn science knowledge or information. When you go to the teaching part, the teaching discourses they use, similar pattern. The red one comparing to the green one. They are framing science practices as a good strategy to teach science as knowledge. Like the sentence. I learned that having a student perform hands-on experiment actually gets the lesson across better. Hands-on experiment is a good strategy for teaching science. And what is science? It's knowledge. It's the information that they need to learn. As opposed to say that, hey, experimenting is science, not a strategy to teach science. You know what is the problem with this framing? If experimentation, if modeling, if argumentation is just a good strategy, then when they go to their own school, they gradually learn other strategy and they forget about experimentation, modeling, and etc. And they substitute it with other positive strategy and effective strategy that they can get in the culture of schools. Instead of assuming that, hey, whatever I teach, my student have to do experimentation. My student have to do modeling because those things are science. I have 3 assertions for the discussion part. The first one is that this perspective of science as knowledge is deeply mediating the way that the students think about science. Is everywhere. As you saw, it's consistently going through the science discourses, teaching discourses, and learning discourses. Science as knowledge, assuming science as knowledge is good, is not bad, but it's just part of the image. It's not actually aligning with the recommendation of National Research Council to assume that, hey, students are little scientists that are expected to do science in classrooms. The other things that I found out is that communicational part of science, when a student talk about science, most of their statement was about, when they were talking about science as practices, most of their statements were about experimentation. But science is not just happening in the lab. Science is also happening when the scientists are talking together, when they are communicating with each other, when they are reading something, when they are writing something. I thought about it. Where does this emphasis on experimentation come from? Well, part of it has to do with like the folk theories in our culture, folk theories about science. Just simply search for the word scientist in Google image. Any guess what you are going to get? Yeah.
White coat.
White coat.
Glasses.
Goggles and glasses. So these are the four theories about science that is everywhere. So when a student think about science as practices, most of their statements implicitly and explicitly were about experimentation rather than communication, argumentation, or writing, reading. The other speculation that I have about this part is that maybe this has to do with the Piagetian theory of learning that is everywhere. In Piagetian theory of learning, the main assumption is that we learn through adaptive encounter with environment. I do something, I'm not good. Again, I do it again. I do it again, I do it again, and finally I learn it through adaptive encounter with the environment. Best example is how we learn games, computer games. You do it first time, second time, third time, and then you learn. If you assume this kind of perspective about learning, then when you are in the classroom, you can think, okay, if I put a student in the lab and give them the material, they play with the material, first time they are not good, second time they are getting better and better and better, and finally they learn science through encounter with the experimentation. The problem with this assumption is that we also learn, we are social creatures. We also learn from each other. We also learn through communication with each other. That part, if we like rethink about how we learn science, then we may see that, hey, the science also has the communicational aspect. It's not just my interaction with the nature and with material world. And the final thing, the interplay between the perspective of science and knowledge and science as practices. Conventionally, we assume that if a student comes to the class with some background, experiences, and knowledge, and we are teaching something else in the class, some students are going to switch from perspective number 1 to perspective number 2 through the interaction with the course. And some students are not. What I found through the data is that, hey, maybe we have another scenario. Maybe they take these background experiences to the class, mix it with the discourses that we are practicing in the class, and generating new ideas, new things that we don't expect. This is actually happened in the data that I analyzed. A student took the science as knowledge to the class. In class, we tried and advocated the perspective of science as practices. They mixed them together and made a new discourse, which says science practices are a good strategy to teach science as knowledge. science practices are good processes for learning science. Awesome. Yes.
Could you share any specific guidelines you provided for your students for this essay activity? How did you?
Well, for one of the essays, we had a structure. They had to write a claim and evidence similar to what like a science paper. You make a claim and then you support your claim with the evidence that you gather. The other one, we didn't have any specific guideline. I just asked them to reflect on what they learned in that week.
When you were talking, it reminds me of the speech that Lauren Roseman gave after the area 1 years ago about non-contextualized knowledge and how we teach math and science in a confused state because we're asking them just to either regurgitate or to memorize, but what we really need to do is be taking practicing from people like drug dealers and Weight Watchers. You know, the drug dealers and Weight Watchers have motivation to get it right. Right? You got food, you've got drugs. And so it seems to me that that is keeping the same resonance argument, that if you contextualize the knowledge rather than just memorize it, then you're doing science in the classroom, you're going to get farther along pedagogically. Is that what you're arguing?
Well, the initial argument was that hey, if a student come to the class and do the science practices, they are going to get it. The problem I found is that, hey, it seems that it's not enough. Practicing science in class is not enough because of those background experiences. They are going to mix those background experiences with the things that they are practicing and making the new things.
Now, when you say background experience, one thing that comes to mind is assessment. Are we running into assessment issues, meaning that we're trying to learn through the assessment lens that we've been talking before, and that's self-defeating? Because the assessment instrument isn't really getting at real learning. Or am I wrong on that?
Well, I have to think of it.
It sounds like you're talking more about the fact that you have to sort of, now we found with students, grad students, who are currently in the practice, that we have to, we sort of have to deconstruct and reconstruct ideas about things, because they come back with ideas about what is science knowledge. It seems like with the subject areas that are less, particularly science and mathematics, sort of that are less in their back pocket, they cling to more of the background ideas, like real life experience. They sort of, it's a little bit harder to get away from some misconceptions they have. I appreciate what you're learning here.
Well, I just want to share a quick anecdote that came to mind that as you were talking, and I think it's quite relevant. I was having a conversation with my son about 2 or 3 weeks ago on a homework assignment that we had, and the nature of the assignment was he had to read an article about atomic energy, and he had to write about how can science help make atomic energy safer. Okay, and he said, Dad, this doesn't make any sense. And I said, well, what do you mean doesn't make any sense? You know, I'm thinking, I'm kind of excited about this because I'm like doing more research and helping with it, whatever else. He said, well, it doesn't make any sense. So why not? He said, well, because atomic or nuclear energy is science. So that just, the question doesn't make any sense. And it's confusing the process, the problem-solving aspect of science as a method versus consuming the outcome of science, which is, in this case, atomic energy, and harnessing it and using it for good. And so it was just, as you were talking about it, that's exactly what's going through my mind. It took me 20 minutes to help them get past that hurdle of separating the process from the results and separating the two. So anyway, it's really, I can see the relevance of what you're doing, and I really appreciate it, what you shared.
Do you know if there's any data or research that shows a connection between between teaching the scientific method and students achieving, having higher achievement in math and science? You know, like, so if teachers actually do teach the scientific method in the public schools, does that result later on in greater math and science skills? Yes, it does.
Yeah.
Oh, okay.
Yeah, it does. It can.
Right, right.
And,
Do you know any gender differences?
well, unfortunately, almost most of the female children. Boy, female. It's the best description of what student that we have here. But it's a good question. I had like 3, 4, 5 male students. I didn't look at the
Okay, thank you very much. Dr. Basir's work is a really important contribution to teacher education as we learn more about understanding science education, how to prepare our teachers beyond the discourse of test scores, high math and science or science test scores. So this is really exciting work. Now we